All right, today we're going to dig into a bug that a ton of developers have probably run into, but maybe haven't fully understood. It's a story about hidden complexity, those unintended consequences, and how the very tools we love to use can sometimes turn against us in really surprising ways.
And it all kicks off with this simple, super frustrating question. So picture this. You're working away in a web app. You click over to another tab for just a second, and when you come back, bam! The entire screen flashes white before it reloads. You didn't click anything, you didn't do anything. So what on earth is going on?
Now, it's tempting to just write this off as some minor visual glitch, right? But it's not. It's actually a symptom, a clue that points to something way deeper going on under the hood in our apps.
Let's just be super clear about what's happening to the user here. They do a totally passive thing. They just refocus the tab, and the application completely freaks out, acting like a massive change just happened. It literally tears down the entire UI, flashes a loading spinner, and then builds everything back up from scratch. This is a bug the user did nothing to cause, but they absolutely feel it.
Okay, so to solve this mystery, we've got to go backstage and look at all the invisible stuff happening. And this is where we run into what's famously known as a footgun. A feature that's so easy to misuse, you basically end up shooting yourself in the foot with it.
So here's the kicker. This bug isn't caused by just one thing. It's a collision between three totally separate systems that have no idea about each other. First, you've got the browser's own visibility API, which just tells a tab if it's visible or not. Then you have an auth library, like Supabase, that uses that signal to quietly refresh your login token in the background. And finally, you have React state and rendering cycle. None of these are inherently bad, but when they slam into each other, it's a disaster.
So, let's watch the dominoes fall, one by one. You come back to the tab, the browser fires an event. The auth library hears that and thinks, hey, good time to refresh the token. But here is the fatal flaw. The code that handles this calls a generic set loading true, something that was probably only meant for the very first time a user signs in. And React, just doing what it's told, nukes the entire user interface to show a loading screen. And boom, there's your white flash.
And if you think that's bad, it gets worse. Other parts of your app can actually make this hidden bug even more powerful. Let's say you add a new internationalization provider that has to wrap your whole app. Well, now when that loading state gets triggered, the blast radius is massive, the flash is bigger, and the remount is way more expensive. The new feature didn't create the bug, it just handed it a bigger bomb. Okay, so we found the bug. Easy fix, right? Should be simple. Well, not so fast. This is where the story takes a sharp turn, and we get to see how the very abstractions in our framework can create their own tangled mess of problems. Just look at this comparison. It's wild. In good old vanilla JavaScript, the fix is literally one line of code. If the event is just a token refresh, then do nothing. Done. Problem solved. But in React, oh boy, it's a whole cascade. First, you have to filter the event, but then React's linter gets mad, so you have to wrap your function in useCallback. Then you might need a useMemo for one of its dependencies, and a useRef just to keep track of things. And before you know it, you're wrestling with 4 different hooks just to stop the screen from flashing. And this right here, this is the heart of it. All that extra code, the useCallback, the useMemo, the useRef, it has nothing to do with the original problem. It's only there to solve a new problem that React itself created. You're not writing your app's logic anymore, you're just managing the framework. You're fighting the framework.
So to really wrap our heads around why this kind of thing happens, we need to step outside of programming for a second and borrow a concept from physics. It's actually a pretty powerful way to think about these impossible-to-trace bugs. The concept is called emergence. And here's a simple way to think about it. Temperature. You can't look at a single water molecule and say it has a temperature, but when you get trillions of them all bouncing off each other, the property of temperature emerges. The whole system starts behaving in a way you couldn't have predicted by just looking at one piece. Now, in physics, this is fascinating stuff, but in software engineering, it's downright terrifying. An emergent property in software is basically a bug that nobody designed, nobody planned, and nobody can trace back to a single cause. It just appears out of the complex soup of all the interacting pieces.
And this really shows us 2 totally different ways of building things. On one side, you have designed behavior. What the system does is a direct, predictable result of the code you wrote. But on the other side, you have emergent behavior, where the system's actions are unpredictable side effects of all its interacting parts. That white flash, nobody designed that to happen. It just emerged.
Now, you might be thinking, okay, this is some theoretical stuff. It probably only affects smaller apps. Well, let me tell you what happened when this exact same dynamic played out at one of the biggest, most important infrastructure companies on the entire planet.
This is a true story. Imagine the company whose entire reason for existing is to protect a huge chunk of the internet from getting overwhelmed by traffic.
And then imagine they accidentally point all of that firepower at themselves, bringing their own services to a screeching halt. That is exactly what happened at Cloudflare. And the culprit? A single React useEffect hook. A developer put an object in its dependency array. But here's a fun JavaScript quirk. A new object is never equal to an old one, even if they look the same. So every single time the component rendered, React saw a new dependency and reran the effect. That effect made an API call, which updated the state, which caused a re-render, which created a new object. You get the idea. An infinite loop, firing a relentless storm of API requests. And the most painful part? The framework's own tooling actually nudged the developer into making this mistake. The result was a 3-hour global outage. And look, this wasn't some junior dev's mistake. We are talking about some of the sharpest engineers in the world, taken down by a subtle, tricky interaction between a quirk of JavaScript and a core abstraction of React. So this all brings us to the big, final takeaway. It's about a fundamental conflict between two very different ways of building software.
You know, when we engineer something, whether it's a bridge or an application, the #1 goal is predictability. We want the final product to behave exactly how we designed it to. We want to eliminate surprises. That's the whole point. And so that leaves us with a really important question we should all be asking ourselves. The tools we pick really do shape our work and the kinds of problems we end up creating. So is your framework a tool for engineering predictable systems, or is it more like a complex medium, a place where unintended, surprising behaviors can just emerge from the shadows? It's a critical question to think about before you write that next line of code.